So the final speaker for this morning's session is James Carpenter from the European Space Agency, who's someone else who has to make it all happen. Where are you? Is your talk
the one with my name on it? Yeah. There you go.
Oh, there we go. Right, okay. Okay.
Thank you very much. Good afternoon. I am going to probably repeat a little bit of what you've heard already. I worked on the assumption that most of what I wanted to say would be said by other people already, so that helps a lot. But I'm going to give perhaps a rather more agency-centric perspective. And we were asked to talk about how space resources can help science and how science can benefit. So I'm going to try and focus a little bit on that, less so on the far, kind of, I guess, the further future stuff that Martin introduced at the beginning, and try and focus a little bit on what's happening now, perhaps what kind of the vision is, what the current planning is, but also what we're doing now and what we can expect in the nearer future. So most of you, I expect, are familiar with the Global Exploration Roadmap. This is what we call the mission scenario of the Global Exploration Roadmap. The GER is prepared by a group called the International Space Exploration Coordination Group, which is a meeting point of agencies. It's non-binding, it's non-committal, it has no authority of its own. It's really a forum where agencies can exchange information and ideas about what their planning is so that they can coordinate with each other a little bit. The way to understand the GR and the mission scenarios here is it's a reflection of what everybody's thinking of doing at the moment. I don't expect that the future will look exactly like this. It's there really just as a guide for agencies to understand what each other are doing and what the future looks like at the moment. This version was released in 2013. There's an updated expected in next year. So this is something that will be iterated. And within this, ESA's own exploration roadmap will also be iterated and be reflected in the next version of the GER. Things maybe I'd just like to introduce you. Firstly is the International Space Station sort of approaching its end during the 2020s, and then the change in the way that low Earth orbit is utilised. And for ESA, the longer term perspective for human exploration post-ISS is that humans will go beyond low Earth orbit and that lunar surface is the next destination for human exploration. And so ESA is targeting this. And this is something that will only be achieved in international partnership, and so we're working on building those partnerships and those capabilities now. The next step, which is being discussed for post-ISS, and we're looking to create this during the early 2020s, is evolvable deep space habitat. So this would be a number of modules located in what is wrongly called cislunar space which is near the moon, and this can move from different places, from Lagrange points to distant retrograde orbits and to other areas. And this is somewhere where crews would go for periods of, say, tens of days to prepare for deep space human exploration later, for future lunar missions, and is an opportunity to do things like teleoperation at the surface of the moon and to do other things. At the same time, we are preparing precursor missions to go to the lunar surface to understand how to get to the surface again, how to work there, how to operate, and how to what resources are there and how we might utilise them. A couple of missions that perhaps worth looking at. The Lunar 27 mission is also called Lunar Resource. This is a Russian-led mission which ESA is involved with. And then the Resolve, which is now become the Resource Prospector mission, which is a study which is going on in the US. So these are both missions which emphasise very heavily trying to understand potential resources at the surface of the moon and their potential utilisation, in particular lunar polar volatiles, which have been discussed already. And the idea is then to leverage off all these things to eventually get back to the lunar surface with a long-term view of a future mission to Mars. And the key word there is sustainable human missions to Mars. So the international community of agencies, I don't think there's any appetite for Apollo-style missions. If we do this, this has to be something which is sustainable and which doesn't stop. Everything should feed forward to something else. So the challenge is, how do we do that? And you'll see there are also lines here for potential commercial opportunities. And so it's also recognised that the private sector is likely to have a role in this, but what that role will be is not necessarily clear yet. And certainly in ESA, I think NASA have done a great job in trailblazing some of these new approaches. In ESA, we're just beginning to explore with some potential future partners what this might start to look like in the next few years. I'll talk a bit more about one of those examples towards the end. The Sustainable Human Missions to Mars, by the way, is an agreed endpoint horizon goal, because as it's been described to me, this is something that everyone in the international community agrees is something that we could achieve together this century. So in terms of where this is all going for lunar exploration, nothing is decided yet of what this might look like, but our Director General in ESA has presented his vision for this, which is what he calls the Moon Village. And I think he's chosen those words quite carefully, because the village is something which is a coming together of different people with different talents, different capabilities, different services, different requirements. And so what this is a community of people. Some of it might be space miners, some might be scientists, some might be tourists. Anybody who has an interest in going to the lunar surface and using the lunar surface to get benefit. And by being together in a community at the lunar surface to take benefit from each other and work on the synergies of each other's capabilities. So this is an idea. I think it's been floated to explore what people think about it and to just raise some questions about what this might be and how we might get there. So the question in all of this is, what would be the role for resources? And we've heard a lot this morning about potential ways of using resources. So I've decided not to go into the detail about any of these, but to say some will be consumables. So we heard about extracting oxygen from regolith, perhaps through reduction. Propellants, using perhaps hydrogen and oxygen from the polar volatile deposits, which we heard about. Or even building and manufacturing materials on the surface. So the image you see comes from a study which ESA ran, working with an architects company called Foster and Partners, a very famous group of architects, on what a lunar base might look like if you built large parts of it using a 3D printed lunar regolith. And we've had a number of technology activities, and something I have certainly observed and been surprised about when we've run symposia and meetings is the extent of interest in the community and the amount of work that's going on in this particular area of additive manufacturing using lunar regolith. But something you'll notice if you look at the global exploration roadmap, and the roadmap indeed of any agency that I'm aware of, is there is no resource dependency in any of those roadmaps. So while what we see are robotic precursor missions, which are in the planning, like for us, which is the working with Russia on Luna 27. I'll talk more about some of our ideas in a moment. There is no resource dependency there, so there is no transition. So the question is, how do we get to yes? What has to happen for agencies to actually start to include the resources of the moon, or asteroids, if that's your target, in your own roadmap? What's that transition point? So while we know, for example, about lunar polar volatiles, that they are abundant in the polar regions, there are significant unknowns still, and there is a prospecting phase which has to happen to define what the resource is and what its feasibility is. So there is no way today that lunar polar volatiles have been demonstrated to be viable to the point where an agency can take any decisions about including it in any kind of critical path. So first we have to prospect and understand the resource. And this is already a big step that needs to be taken. Then we need to verify the capability of being able to extract it. And then we really need to demonstrate this end-to-end process from the extraction to the utilization. Now today I don't think we know exactly what this step looks like, what it is that needs to be done to be able to make this change in the way that exploration is planned. But I think that's perhaps a discussion for the resource community and for others to try and work out what do we think needs to be done. It's a question for agencies to try and work out what do we think has to happen to make this transition. But an important part of all of this is going to be to establish what different roles are. So there is a public sector role in all this. So agencies are, at least from the agency roadmaps, they're sort of running the show, defining what their goals are and what their stakeholders want. But there is also clearly a role for the private sector, and we've heard a lot this morning about the kind of things that the private sector are thinking about doing and opportunities that they see. And I think that we are interested in looking at what private sector interests are and what opportunities there might be for partnerships between agencies and the private sector, particularly in these early phases, to enable both parties to benefit off each other's capabilities and to look at the way that risk sharing might work. And a part of that also is, I think, private sector taking initiative and approaching agencies to explain what they want to do and what investments they're prepared to make and what they would seek to do and what their model would be for private-public partnerships. There is a certain amount of trepidation in the public sector about public-private partnerships because PPP, I've heard described to me by several senior managers as public perpetually pays. Right, so there is a certain fear about this, and so this is something where I think more and more we're looking into trying to understand how this might work. But I think it's very, very clear is that none of this can happen without the science community taking a role. So all of the prospecting we've done so far, the things that Paul was talking about in his talk about understanding the distribution of lunar polar volatiles, the hydrogen that was there, the compositions, all of this comes from the science community. And the science community have to continue to be involved and will play a role. And I think along that process, the science community will also gain benefit from this. And so I'd like to think about what, in the nearer term at least, benefits the science community might get out of this work. And through what we're talking about at the moment, which are the near-term robotic precursors. Now, there are lots of different potential resources on the moon. We talked about several of them, but the low-hanging fruit, if you like, the one that people are really focusing on, I think in international discussions within ISEG, for example, are lunar polar volatiles. This is the very sexy one that people want to talk about and people are looking at and trying to understand better. Now, this actually comes from a nice white paper that's been paired by a group called the Friends of Lunar Volatiles, which is coordinated by Dana Hurley in the US. And they produced a white paper to say what is the current state of knowledge on these lunar polar volatiles and what are the big questions that remain. And how do these compare in terms of the science objectives that we might have in terms of to understand these and the objectives that you as exploration people would like to know in terms of the feasibilities of resources. And it turns out that the kind of measurements it's not surprising, the kind of measurements you make to do resource prospecting also turns out are extremely scientifically interesting. And these polar volatiles are fundamentally scientifically interesting. Where they come from, the way the processes that have put them there, the way that they've changed over time. There was a quite wonderful paper published even a couple of weeks ago by Matt Siegler in a Nature paper, where they've try to explain the rather bizarre distribution that we see for these volatiles in terms of a wonder of the location of the lunar pole over time, which perhaps is related to the formulation of the Procalarum area on the near side of the moon. Now, I think this is a wonderful thing. It kind of starts to explain why the polar volatiles that we see on Mercury and on the moon are so different, but it also implies that if this is why we have this distribution that we see on the surface of the moon, then these polar volatiles are quite ancient. And that makes them, I think, quite exciting in terms of understanding the volatile delivery to the inner solar system and even to the Earth. So I think that there's a really interesting fundamental scientific reason to want to explore these, and resource prospecting can be a really good way to motivate the missions that will get that information and do that science. So here's a first example of that happening now. Oh dear, 2 minutes. Okay, so this is Prospect. Simeon Barber from the Open University is going to talk about Prospect in detail this afternoon. Prospect is a package we're developing for the Russian Lunar 27 mission. It will land in the polar regions. It will drill down beneath the surface. It will extract samples, heat those samples, extract the oxygen, water and other volatile chemistry from those samples, and then make measurements of those. And the goal is to make laboratory quality measurements to establish the origins, the quantity, the abundance, and the chemical composition of these volatiles. This has been motivated by, and is paid for the human spaceflight program in ESA as part of future human exploration. It is an extremely powerful scientific instrument and scientific package. It will produce science. This is in phase B at the moment, and we expect it to have operations at the lunar South Pole on Lunar 27 during 2021, and you'll hear more about that this afternoon. So that will produce science, but on the way to developing this, we have to do a lot of science. So we have what we call the Prospect user group. This represents a broad array of users, some scientists, some engineers, people involved in public engagement, and different people who might use this package and extract benefit from it. We have at least 2 PUG members in the audience, so it's Mahesh Anand from the Open University and Roman Tartesi from the Natural History Museum in Paris. And one of the roles of the user group is to do the science that creates the requirements and the understanding that we need to be able to do this. So we're looking at things like volatile process in the lunar environment, understanding polar regolith and its properties, but also analysing samples of materials we have at the moment and creating some of the standards that are going to allow us to calibrate our measurements. All the way, this is things that we're starting at the moment, but all the way through this process, we will do science all the way to flight. So following on then from Prospect, and also we're saying that part of the PUG's job is to engage with the broader user community. So if you have an interest in this, there are ways that you can become involved and engaged in the work that we're doing on this and then future missions to come. So we tend to follow this up with, we have a pre-phase A study going on with 2 industrial contractors on a lunar volatile prospector, which was basically take the single point measurement of prospect and we stick it on a rover, and now we prospect a larger region in the polar regions of around 50 kilometres, going to different environments with different levels of sunlight, different thermal environments, in order to create some ground truthing for some of the orbital measurements that we have and to understand this broader distribution. We have a lunar polar sample return mission concept. This isn't directly, I guess, related to resources, but one thing it does turn out is that if you want to explore and get measurements from inside a permanently shaded crater, sample return is actually not a bad way to do it. At least one of the Russian lunar sample return missions in the 1970s landed, sampled, and returned all during lunar night. So this has been done kind of in the 1970s already, and so you can do a rapid turnaround. So there's interest from this also in terms of resource prospecting. The final thing, which is starting soon, we're going to be exploring the role of small sats might have to play in this. So from that we have things like CubeSats, penetrators, and small platforms. And with these, I think you have a role for really highly focused investigations. So penetrators, for example, are things that you could have small penetrators going to multiple regions across the poles, making measurements in different environments, which are fairly simple measurements, but which really give you a distribution of ground truth, which you find very difficult to do from single point missions. So we can also have a much broader participation here. Now, 2 things that are relevant to that, which are to look out for. The first is an emerging private sector partnership with SSTL. We're now we call entering into a pilot phase, so there's no commitment from anybody at the moment, with Surrey Satellite Technology about a potential partnership which would see small sats delivered to lunar orbit, and then providing perhaps support for the development of these platforms, but then also communication services for these platforms. And there's also going to be a competition published soon, we hope, to explore some mission concepts, looking at resource prospecting, understanding environment, and fundamental research, technology development activities using small sats. So keep your eyes open also for that competition, which will be announced soon, we hope. And so then just to finish, I think just to summarise, lunar resources are not yet on the roadmaps, but getting there, getting to yes, is a motivator for agencies to invest. So we are preparing prospecting missions now. We have to follow those up with validation and demonstration. Private sector partnerships are going to be important in this. And science community engagement is essential. But when science engages with this, science will also get benefit all the way through that journey. And with that, thank you.
So the more time we have for questions.